Hello, this is Lucy Taylor, and I am presenting my work for Module 3.2, Technological Design Integration. The metrics for my site are the 56,000 square feet. The mast building program that I have designed has a gross floor area of over 118,000 square feet, which does not include the parking area. Of that, a little over 80,000 is dedicated to residential zoning. Almost 11,000 is for commercial zoning. 8,600 is for resident serving services. 18,000 square feet approximately is dedicated for community serving services, and then separate from the total is 26,000 square feet of parking area under the south wing that provides 68 parking spots. Of the residential zone, the total fits 30 one-bedroom / studio sized units at 400 square feet each, plus 25 800 square foot 1 to 2 bedroom units and 16 2 to 3 bedroom units at 1,200 square feet each for a 71 units. The building covers 50% of the lot, and I ran calculations with the proposed building features that we'll discuss on the following pages. The projected annual energy cost is 79 cents per square foot. This is my massing diagram showing the color-coded zones for residential, commercial resident services, community services, and then the circulation to get to the upper levels. The parking is accessible from the rear alleyway, and the front of the building is one level underground. These are my passive sustainable design strategies. The first one is the green roof, which is constructed of structurally insulated panels. There's a cross section showing the detail of that roof construction, which has the panels topped with waterproof membrane, drainage system, soil, and then the planted layer. The reason I chose the green roof is because it captures rainwater, it lowers cooling costs, it reduces the urban heat island effect, and increases the acoustic and thermal insulation performance of the roof. The reason I chose the structurally insulated panels, after doing some research, they make construction quicker because they are assembled quickly on site because they're prefabricated, which leads to more accurate construction, which saves cost. And in use, it makes a more energy efficient building by minimizing heating and cooling costs. The other passive strategies I employed were paying particular attention to the building orientation and how that can optimize ventilation, daylighting potential, and control solar exposure. Also controlling the solar exposure and aiding in natural cooling are the generous 15-foot deep overhangs on the north and western facades. And my other passive strategy involves the landscaping. I reserved 50% of the site area for landscaping to maximize the green environment, to create as much shade as possible, as much space for play and gardening, and facilitating social interaction outdoors, and reaping the health benefits of interaction with nature. The active design strategies for sustainability that I chose are solar energy production through the use of these solar trees. They're basically canopies, which, while they're providing shade and cooling, they are generating clean, renewable energy. They're easily installed and can be tied into the grid. And we have plenty of area, both on the building and in the landscaping, to plant enough so we could generate a decent annual electrical output of at least 360 mega kilowatt hours with an assumed solar panel efficiency of 15%. The other active strategies that I would like to use are using insulated concrete forms as the construction method. It's supposed to be strong, which is suitable for a taller building. It provides high insulation, which is suitable to the hot climate. It provides superior resistance to moisture, fire, and wind elements, and also provides superior soundproofing, which is great for such a dense multi-unit building. The windows specified are double low E glass. The window to wall ratio is at least 60%, which affords ample natural daylighting and maximizes the view opportunities. And the windows are operable in every unit, so the users can control the cross ventilation. Another active design strategy is the on-site water management, capturing the rain and storm water as well as all the gray water, and reusing that for the landscaping and the green roof. It's a quick diagram of showing the service cores in each level and the electrical ventilation and wet system distribution between all those cores, and subterranean, the rainwater and gray water tanks. This is a floor plan of the entire third floor, showing the location of the color-coded residential units, and then the common areas, circulation, and the service cores. This is a building section, also showing the service cores and the distribution of the electrical ventilation and wet systems, and the utility room, which is at the garage level. There is a floor plan of a typical unit, the most common unit, which is the 1-bedroom, 400 square foot unit, showing the location of the service core. It's a set of the sheets which show all the in-progress views. I will attach the PDF of the complete set to the end of my submitted PDF for this presentation. Thank you for watching.